Hello, in this video I will explain different joint types that we can use in CoppeliaSim, ReRep robot simulation software. The aim of the presentation are to understand the different joint types and how do they describe movement between objects, to know different joint modes, to implement torque force control, velocity, position control, or even a motor-free mode. And finally, another objective is to understand when the joints have to work dynamically or statically. There are three types of joints: revolute joints that allow turns around the joint axis, prismatic joints that allow linear displacement on an axis, and spherical joints that allow changing the orientation arbitrarily. Joint size is not important, it's just simply an aesthetic aspect. The important thing is the direction of the axis and the position value, angular or linear, depending on the joint type. Both revolute and prismatic joints have 1 degree of freedom, while spherical joints have 3 degrees of freedom. Indeed, they can be seen as 3 revolute joints intersecting at the same point. Joints allow relative movement between the parent and the child object. When a hierarchy relationship is established between a joint and an object, it will move according to the position of the joint. In the case of an articulated robot arm, the robot links moving according to its joint position will change. Joints may have physical limits where the position must lay. This is clear in the case of a robot arm, while wheels of a mobile robot can rotate, let's say, unlimited. Joints can be passive, that is, joints that are not directly controlled, and they are fixed, although their position can be modified through programming scripts. On the other hand, joints can be dynamic if we set the torque force mode, so they can be controlled through the physics engine. They can be actuated or non-actuated, and the reference values can be set through programming scripts too. Finally, joints can be in inverse kinematic mode, so the inverse kinematic module controls the position of the articulation, or a joint can be also in dependent mode, which means that its position depends on the position of a different joint. When a joint is set in torque force mode, it can have a free movement if there's no actuator. In the case of using a motor, then the speed of the joint can be modified or can be controlled if we do not activate the closed loop control. But if we activate or we enable the closed loop control, then we can implement a position control using a PID, or we can implement an impedance control acting as a spring damper. Speed control is quite simple. If the maximum torque of the joint is high enough to move child objects, then the speed of the joint will be equal to the reference speed, and this happens instantaneously. If the force is not enough, then it will gradually increase until it can be reached, as long as the maximum torque allows it. This mode is suitable for speed control of wheels of a mobile robot, or even, for instance, a kinematic control of an articulated robot arm. Position control of joints uses PID control, which sets in the end the joint speed. This is the most convenient way if you want to establish a position control of an articulated robot arm, but you don't want to consider all the complexities of implementing a pure dynamic control, for instance, in order to compensate gravity. This is more or less equivalent as using RC servos in a robot arm, and let's say that you establish the reference and that the RC servos are in charge of regulating the position. Tuning of PID control parameters or constants is an advanced topic, and this will be seen in another video. If, on the contrary, we intend to perform a force or impedance control, we can establish viscoelastic constants of a spring damper system. This may be convenient for instance, in the case of robots with elastic joints. But again, this is an advanced topic and this will be seen in another video. When using joints, you must take into account if the object that you are moving is static or dynamic. For dynamic objects, we must use the force-torque mode or activate the hybrid mode. If the object is static, you can use either a passive, inverse kinematic, or dependent mode, but then you cannot use the hybrid mode anymore. There's a mode in which we can expect, or there's a tool in which we can expect if an object is dynamic or static, and this will be very useful whenever we need to detect if we need to set the joint in dynamic or in a static mode. In this video, I have shown different joint types in CoppeliaSim VREP. On next video, I will show you how to work with joints using the simulator and how do they respond under different configurations. Thank you very much.